Hey guys, welcome to the video for correlation. We're also going to be talking about linear regression as well as association, causation, and how that relates to different things. Our essential question is, how do mathematical representations help us understand linear relationships in the world around us? So the first word we're going to talk about today is correlation. And the definition of correlation that I'm going to use is the relationship. I'm spelling relationship wrong, oh my gosh. Relationship between two things. So it's going to be the relationship between two things. So whether we're talking about how many calories you're going to burn versus how long you've been running on the treadmill, or the temperature outside and whether your ice cream's going to melt fast or slower, stuff like that. Now there's three types of correlations that we could possibly see, and we see those types of data on scatter plots. In the real world, when you're taking surveys and when you're collecting data, you're not going to have a perfect straight line like we have had in the past when we graph, right? We have a y-intercept and then we use our y-intercept and our slope to graph our linear equation, and we have a perfectly straight line because the slope is constant. But in real life, when we're collecting data, for example, if I go around and I collect everybody's shoe size and everybody's height, we'll see that most of the time, the taller you are, the bigger your shoe size is. But that's not always the case, right? Just because you're not a certain height does not mean that you cannot have a certain shoe size. So it can vary because, this is real life and there are variables to everything. So we're going to go ahead and kind of talk about that. So if you notice in this first graph, this is more of a positive trend. The line is going, or the points are going upward from left to right. So this would be considered a positive correlation. Over here, we have a trend where it starts at the top and starts to go downward as it goes from left to right. So this is also known as a negative correlation. And when the points are kind of all over the place and they're not really related and there isn't really like a pattern happening, that's when we kind of say no correlation, or they're very weakly related to each other. So some examples, I'm going to give a positive is, example, the amount of time you study and your test grade. Now, this also brings into the variables of, it depends on the person. It depends because this is real life and there are many variables to things. So typically, the time that you spend studying, or the more time that you put aside to actually get better at something, you're going to be better at that one thing, right? So if you're studying for your English test, you're typically going to do better than maybe a person that didn't do any studying at all. If you're not practicing every day in whatever sport you're in, then maybe that sport that you are in, you're not going to be as skilled in certain things as people that have been practicing that one certain skill. So, but at the same time, right, there's people that make A's on tests that never study at all. So again, there's variables, right? Typically, yes, if the more you study, the more time that you put into it, the better that you will be, or the higher grade that you'll probably get on your test. But that is not a guarantee. So that's why it's a scatter plot, right? Because it's not a guarantee like, oh, if I study for 5 hours, I'm going to be making an 80, but if I study for 6, I'm going to make a 95, right? There is no math equation or anything that can say, oh, this is what we need in order to make this. It's just kind of, it varies, right? We're humans, there's errors that we make, and so it's not 100% every single time, but it does typically show a positive trend. So what to note here is that as your x value increases, as it goes up, then your y value is also going up. So for example, if you notice, as I go from this side of the x-axis from 0, 0 towards the right side, you'll notice that my points are going upwards. And same thing here, as on my y-axis, my points are also going upwards, right? So as my x values increase, my y value increases. For example, the longer you study, the more likely that you'll have a higher grade. The less time you study, you may have a lower grade. But again, there's variables to everything. It's not a guarantee. Now, if we have a negative correlation, for example, let's say the amount of time, I like to use time as an example because it's pretty easy. The amount of time you run on a treadmill and the number of calories. Not even number of calories. How about, and let's use body fat percentage. So, and your body fat percentage. All right, so example, right? If we're running on a treadmill, we're constantly working, we're moving, right? And so when our bodies are moving, then we are burning calories, and in that case, our body fat percentage is decreasing. It doesn't decrease by a lot, but it is decreasing, right? So this is a negative correlation because the longer you do that, the less body fat you will have, the less body fat percentage you will have. So in this case, as your X value increases, so as you continue to work out, the longer that you work out, right, as your time increases, your X value increases, your Y value will decrease because that body fat percentage is what we're talking about here, that will decrease. So if you notice, as we're going from left to right here on our x-axis, again, we are increasing in x values, but as I'm going on my y-axis, you'll notice that the points start up at the top and then eventually go downwards. So your y values are decreasing in this case. Now something with no correlation, I'll go ahead and give an example of that. That could be literally anything that are two things that aren't related. So the number of pets you own and your shoe size. Right, those two things are not related, obviously, because the number of pets that you have is not going to determine what size shoe you are, right? Those are two completely unrelated things, so that's what I mean when we say no correlation. All right, now the cool thing is that our calculators can actually help us out when we're calculating for correlation, kind of telling us the strength between those things, and that's represented by the letter R. Now we'll talk about that later as we get into linear regression and actually calculating that in the calculator, but the R value in your calculator, which is very important for you to know, so I'm going to go ahead and put a little star here. We do need to know what the R value is. Your R value is going to tell you how strong two things are. So, for example, if I'm talking about my number of pets that I own and my shoe size, that's going to be a fairly weak strength because they're not very strong because they're not very related to each other. But if I'm talking about the amount of time that I study in my test grade, that's going to be a stronger relationship. And the amount of time that I run on a treadmill and how much body fat percentage I have, that's also going to be a strong relationship. But there are, again, different types of relationships here. So your calculator is going to give you an R value. And your R value is always going to range between -1 and 1. Before we get into that, let's go ahead and define what a correlation coefficient is for us. So that is a number between -1 and 1, and it tells us how closely, let's just use the strength, it tells us the strength of a relationship, how strong two things are compared to each other. So a number between -1 and 1, and it tells us the strength of a relationship. All right, so as you see here, I have a giant number line, but the number line only spans from -1 to 1. You will never see a correlation coefficient go past -1 on the left side, so you'll never see like -2, -3. You'll also never see it get greater than 1 and go past 1 at 4 or 5, right? It's going to have a maximum of a 1, and it's going to have the lowest amount, which is going to be -1. Now, your correlation coefficient can be any number in between, so that's going to be some decimals. And your calculator will give you decimals because, again, in real life, nothing's really that pretty when we're calculating for slope and all those things because it's an estimation, right? It's not going to be perfectly straight when we're graphing things because when we're collecting data, it's mostly going to be a scatter plot. Now, on the negative side of the number line, from 0 to -1 here, from 0 all the way to -1, those are your negative values because it's on the negative side of the number line. So that would mean that you would have a negative correlation on that side. Whereas if you're on the right side of the number line, from 0 to +1, you're going to have a positive correlation. And typically when it's in the center, you could say that it's no correlation, but it's also just fairly weak. So we're just going to go and say that if it has anything near 0, that it's a no correlation. And when I'm saying near 0, we're talking about decimals here. So you got to think about, 0.01, 0.3, 0.2. And then numbers that are on the positive side could be 0.5, 0.9, 0.8. But you could also have negatives. You could also have -0.9 and -0.7 and -0.3. You can have all of those things. So I'm going to go ahead and kind of show you some pictures of what these things might look like, and then I'm going to go take you to a website to kind of show you what that looks like when we are talking about our R values. So I'm going to go ahead and first start off with, let's say that my R value is straight up -1. Like if my R value is -1 here, the most negative R value I could ever possibly have. That means that when I'm collecting my data and I plot it on a scatter plot, it's going to make a completely straight line. All those points are going to completely make a straight line because it is the most negative that it can possibly be, which means everybody's in order. There's an exact trend. So this is what we would really call a really strong negative correlation, or just a strong negative correlation. So I'm going to go ahead and say a really strong negative. Because remember, this tells us the strength of those two things. So that means that whatever two things we're talking about, if we get -1 or anywhere near it, then it is a very, very strong relationship. But let's say my R value is still negative, but let's go into the realm of -0.893. So then you have to think about, is -0.893 closer to -1 or is it closer to 0? Now we know it's on the negative side of the number line. Now, by the way, if you did not know, this is a -0.5, right? Because 0.5 is halfway in between 0 and 1. So we have 0 and -1, and we have -0.5 in between. So where does -0.893 land? Well, that's going to land somewhere probably over here on this side. So would you say that's closer to -1 or closer to 0? It's closer to -1. The closer it is to -1, the more strong it is on the negative correlation of things. So we do have a strong negative here, but it's not going to make a completely straight line because there's variability here. So you might have scatter plot data, but it's going to be a little bit more spread out. You can kind of tell that it's negative, right? You can tell based on where the points are headed that it is more of a negative correlation, but the points are going to be more spread out at this point. So let's say we have a correlation coefficient of 0, which doesn't really happen a lot. And I'm going to go ahead and say that correlation coefficients of -1 and +1 don't ever really happen that much either. But if it does, that's what it would look like. Now, if our correlation coefficient is straight up 0, that means that those two things aren't even related. So you're going to have random points everywhere on this graph because nothing is related to each other. So it's all over the place when you survey people and try to collect data. So I want to go ahead and kind of just say no correlation here. All right, now let's go on to the positive side of things. So I don't know if you've noticed, but I kind of matched it to where I have some negative examples, and I'm going to give you some positive examples. So let's say our R value is 0.329. Now, 0.329 is a positive number. Why is it not negative? Because it's not a negative sign. You'll notice if it is a negative correlation coefficient that it'll have a negative sign in front of it. And if it's a positive correlation coefficient, then there isn't a negative sign in front of it. And it also is very important that you understand that correlation coefficient, remember, is telling us the strength. So there's a lot of vocab that we gotta learn in algebra in general. So this is another word to throw into that mix. And the letter R represents correlation coefficient. Now, if I have R values 0.329, I got to think about whether that would be a stronger positive or a weaker positive, or if there's really no correlation happening. Well, if this is 0 and this is +1 and halfway in between is 0.5, right? Where does 0.329 land? Well, 0.329 kind of lands right over here in between 0 and 0.5. Because it is closer to 0 than it is closer to 1, this is something we considered a weak positive. Yes, it's a positive correlation, but it's fairly weak. It means there's kind of a relationship there, but it's kind of a stretch at that point. So when we plot this data, the points are going to be really spread out because their relationship is not close and bonded together. So your points are going to be more spread out. You can kind of tell that it's positive, but again, it's kind of hard to tell that it's positive, but you can kind of see that upward trend. And then our last example here is R equals +1, which is the most positive you could be. You cannot get any more positive than that, so that means that when I graph something like this, I will have a completely straight line. And just to remind you that not all lines have to go through 0, 0, so my line does not. And this is something we would call a really strong positive or just a strong positive in general. So I found a simulator online where it kind of helps us talk about R values and all of that stuff. So I'm going to go ahead and kind of show you. So if you look on my screen here, go ahead and there we go. If you look on my screen here at -1, notice how my lines are it's a completely straight line and all those data points are going downwards. But if we go +1, whoops, if I drag this all the way to +1 here, you'll notice that all the points are now going upwards this time. Well, what happens if I do 0? And you'll notice it's kind of all over the place. If I have 0.4, maybe, it's kind of getting more positive, and then I move it to maybe 0.6 almost, and it's getting more positive, maybe 0.8, and it gets more positive. So the closer it is to a 1, the more tight the points are going to be aligned with each other. And if I go to like maybe 0.92, you'll notice that those dots and those points are even closer together. Because once you get to positive 1, then they're all just straight up in a line. Same thing on the other side. If I have maybe negative 0.3, that is a negative correlation, but it's fairly weak. The points are kind of scattered still because it is fairly close to 0. But the closer I get to negative 1, you'll notice the points start getting closer and closer together. And as I get to 0.75, it is closer. And then negative 0.94, and that's closer. And then once I get to negative 1, then obviously it's very, very straight. All right, so that's just kind of a little intro to your correlation coefficient. And again, your calculator does the calculation for you. You just need to be able to interpret what that might mean. So if the calculator says your correlation coefficient is 0.67, you're like, okay, well, 0.67 is above 0.5, so I'm going to say that's a stronger positive. So we'll go ahead and do some examples over here. So your calculator is going to give you some R values. So each time it's going to give you 1. So let's say the first time you do it in the calculator, it says 0.17. You're like, okay, 0.17. That's positive for sure because that's a positive number. But because it is closer to 0, that's going to be considered a weak positive. So weak positive. And if I have maybe 0.897, 0.897 is really close to 1. It's fairly close to 1, and it is positive. This would be considered a strong positive. And then let's say I have a negative 0.682. Negative 0.682, now that is a negative. So we have a negative correlation here. And then you have to figure out, is this is this a strong or is it a weak? Well, because it is closer to that negative 1 rather than the 0, it's considered a strong negative or a fairly strong negative. All right, so let's go ahead and move into the section where we talk about association and causation for a little bit. So there's two types of correlation when we talk about relationships between two things, when we're talking about real life things. There's association and then there's causation. Association, that is two things. I'm just going to say things because two things, so it could be anything. Two things that are related. Oops. But not 100%. They're two things that are related, but they're not 100% related. And then causation are two things that are perfectly related. And the way to kind of remember this is the word association. It has the word associate in it. They're associated with each other. They're related with each other. They're kind of familiar with each other. But it does not mean that these two things always have a relationship. Whereas the word causation has the key word cause, so it's going to cause it to happen 100% of the time. Oops. And then association means, again, they're related, but it's not 100%. So you might want to think of maybe, again, studying with your test grade. Those things are associated with each other, but studying does not cause you to make an A. It does not cause you to make 100 on that test. So just be kind of familiar with that. And then that's also going to affect your R value as well, because when we have association, those are things that are really strongly negative, or they can be really strongly positive, but it doesn't necessarily mean that it's perfect every single time. Whereas with causation, you're going to have that negative one, that positive one relationship. All right, so we're going to go ahead and do some examples. Now, the thing before I start this, actually, let's go ahead and go back. If something is association, then automatically it is, if something is causation, so if it is causation, it is automatically association too. Why is that? Well, if two things are perfectly related, then automatically aren't they related in general? So if it's association, it does not mean that it's causation. But if it is causation, automatically is also association, because association just means that they're related. Causation means they're related and it happens all the time. So if it is causation, it is automatically association. So if something is causation, you would say that they're both. All right, so let's go ahead and do some examples here. Determine if the following examples are causation, association, or neither, and sometimes maybe both. Number one, a teacher's salary depends on the number of pets they have. Well, we're talking about a teacher's salary, how much money that person makes at school, and the number of pets that they own. Well, if we look at these two things, are they really related? Does it matter? Does it affect that? And no, it doesn't. So this would be a situation where we have neither. Okay, a student's test score and how long they study. Well, again, we talked about this. The longer you study, typically you do have a better grade, but there's no guarantee. You studying does not cause you to make an A. So this is a situation where we have association. And then lastly, the weight of cheese depends on the amount of milk used. Well, if I use a lot of milk, so let me go ahead and underline this. The weight of cheese, right, depends on the amount of milk used. If I use a lot of milk, I make a lot of cheese. If I use less milk, I make less cheese, right? Because it would just depend on how much milk I use. So if I use like 20 gallons of milk, I'm probably going to produce more cheese. But if I use 1 gallon of milk, I'll be producing less cheese. No matter what, though, I'm going to be producing cheese in whatever quantity depending on how much milk I decide to use. Now, this is a situation where you do have causation. But because it is causation, it is also association, because these two things are related. So I'm going to put a causation and association, and also in parentheses kind of put both. Because if it is causation, again, if it causes it to happen, then automatically they are related, so it is also association.